processor and microcontroller. In this lecture we will be continuing with the different pins of the 8085 chip. Okay, so in this lecture let's start with pin numbers 21 to 28, which are the higher bits of the address bus. So before moving forward, let me just refresh the concept of the address length and data length of the 8085 processor. So basically the 8085 processor has a 2-byte address bus or address length. Okay, that is, it has 16-bit address. 16-bit address. So let's say it is A0 to A7 and A8 to A15. So when it comes to the pin diagram or a pin layout of the processor, what is done is this group is it is considered as one group, and this is considered in another group, the higher order pins and the lower order pins. That is the address bus. When it comes to the data bus, it has a 1-byte data bus or length. That is, for the capability of the processor, the ALU, the register length, all of those will be 8-bit. So it is D0 to D7, right? So that is the address bus and data bus. So these pins 21 to 28, let's see where they are. 21 to 28, they are obviously A8 to A15, which is the higher byte of the address bus, right? And they are given as outputs because the processor just gives out the output, right? It gives out the address to the memory. It doesn't take back address. It generates the address and gives the address to the memory, whether it's a read or write operation. That is regarding pins number 21 to 28. And please remember this. The address bus is split into two, higher and lower. So this is the higher and lower. Okay, moving on. The next set of pins is pin number 12 to 19, which is coming here, right? 12 to 19. So if you see here, it is address, lower part of the address bus bar data bus. That is, it can either act as sorry, let's change the color. It can either act as A0 to A7 or can act as D0 to D7. Okay, so what we are doing is, if you just use this earlier picture, we are combining these two. That is, we are combining 8 bits of lower address and 8 bits of data bus. We are combining these two into, basically, instead of using 16 bits or 16 pins, we are using 8 pins. Okay. Dual purpose pins. And if you observe here the lines, right, every other pin is either an input or an output, right? It is either an input or an output. But this one, these are both given as input and output. That is, they are bidirectional. there are bidirectional lines. But earlier when we considered this address lines, higher byte of the address, it was unidirectional, right? It was only going outwards. So again, for the address part of this line, that is required. It need only act as output. But for the data path, it has to be bidirectional, because the processor will execute or implement both data read and data write. So for data reading, these lines should act as input lines, and for data writing, these lines should act as output lines. Therefore, these pins, these 8 pins, they will be bidirectional in nature. Can act as either A0 to A7 or let's say AND, because it acts as both, but only one at a time, and D0 to D7, right? So this concept is called multiplexing of address and data bus. Okay, so to retrieve our required data, what do we have to do? We have to demultiplex, right? We have to demultiplex the address and data AD0 to AD7. So how it is done is, we'll see that in detail a little bit in next couple of slides. So before that, let's just show the basic. How it is done is, during the first clock cycle, these lines, that is pin number 12 to 19, act as address bus lower, right? And second clock cycle onwards, pin number 12 to 19 act as data bus, right? It act as data bus. So if we just draw the let's say AD 7 AD0, okay, and we have a clock here. So suppose this is the first clock cycle, and we have our data here. We have a lot of data here. Let's just redraw that. Okay, so during the first clock cycle, what happens is that this acts as the address bus lower, okay, and from the next clock cycle onwards, for how much ever clock cycles are there, these lines act as data. This is how it happens, right? But the thing is that whatever address we require, we have to take it at this before this changes to data bus, right? Because otherwise this address part will be lost, right? Because the information at the lines changes. To avoid that, what we do is, we use the concept of an address latch. And to use the address latch, we are using the pin address latch enable, which is pin number 30. Okay, so we are using address latch enable pin, or pin number 30, to use something called as an address latch, which is in turn used to save the address, lower bit of the address, before the pin numbers 12 to 19 change from being an address bus to a data bus. is that is address latch enable pin, right? If it is 1, whatever data is there in these pins 12 to 19, it is considered to be address, or these pins act as an address bus, again lower. And these whenever it is ALE is 0, it acts as data bus. Okay, so this is the processor sort of generates this as a signal, but from the designer point of view, this signal is used for enabling and disabling the address latch. Okay, so you can think of this like this, or we can use the previous slide, right? So if we have our ALE, what is the condition during the during when the lines are address bus, it is 1, right? It is high, and after when it becomes data bus, or that is after the first clock cycle, it becomes low. This is how this signal changes, right? And if you can let me just change this. I'll draw it here. So suppose ALE is 1 here, and after it changes to data bus, it goes like this, becomes 0. So how will A8 to A15 change during all this? It doesn't change. It is always address bus higher. Okay, this is how our pins AD0 to AD7, A8 to A15 and ALE change with respect to the clock. To what to do to implement this concept, demultiplexing of address and data bus. So let's see how that demultiplexing is done in detail. Okay, so this is the hardware structure that we are using for demultiplexing the lines. This is the hardware structure that we use for demultiplexing address and data, right? So here we have our pins, concerned pins A8 to A15. Does it require any latching or changing or anything? No, because throughout the operation it acts as the higher order address bus higher, so we can directly use it as address. So no change here. It is only happening, the change is only happening here. So what happens? We are connecting these lines to the input of a latch. Okay, again latch. What is a latch? Address latch. Latch is a memory element, memory unit, which retains whatever input is there at the whatever data is given at the input at the moment when it is activated, and retains it. So suppose we give some information here and we enable the latch, that will come to the output. But after the latch is enabled, no matter what changes come here, it won't reflect here, right? It will not reflect here. So whatever data was here at the time of enabling the latch, that will be secure here, no matter what the changes come here. We are using that property of the latch for saving the address, saving the lower order address, and using these lines as data bus, right? So obviously there is no change here. During the first clock cycle, what happens? The lower order of the addresses come here, again it is reflected here, and just as the second clock cycle comes, the address ALE is made to 0, that is the address latch is activated, right? The address latch is activated, and whatever data was here, it is fixed here, it won't change again. And then from next cycle onwards, these lines, right, these lines here, these lines act as data bus, and that changes, it is reflecting here, right? So we are just taking a parallel sort of lines. So we have our data bus here and we have our address bus here. So basically we are saving 8 pins, and at the time when this processor was released, 8 pins, saving 8 pins was a huge deal. It was a big deal. Okay. So just I want to go through. We just considered one group of pins actually, right? The address and data bus group, the higher order address bus, and the lower order multiplexed address and data bus, and the concept of address latch enable, and how we are using a certain latch, address latch, to demultiplex address and data lines. So in the next lecture we will continue with the remaining pins, and we'll see. Thank you.